Welcome to this explainer. Okay, let's just dive right in, because right now, there's this massive, industry-wide confusion between two AI terms that recruiters, hiring managers, and startup founders are quietly judging you on. You hear these phrases literally everywhere in tech today, but blurring the lines between them, it can actually cost you a job offer. Just imagine sitting in a final round technical interview. The stakes are high, and you completely misuse a core architectural concept. Or picture mapping out a product roadmap and accidentally committing your startup to a vastly overcomplicated system, all because of a buzzword. Yeah, we're going to make sure that doesn't happen to you.
AI agent versus agentic AI. You've probably seen these terms used totally interchangeably by LinkedIn influencers, thrown around in job postings, and even used by some tech analysts. But are they actually synonyms? Do they describe the exact same underlying technology? Absolutely not. No way. So here's the crucial point. If you want to sound credible in your next interview, or if you're trying to build smart, cost-effective products, confusing these two is a massive industry red flag. If you call a simple Python script agentic, developers are immediately going to know you're bluffing. Why? Because under the hood, the architecture of these two systems is entirely different. Honestly, it's like calling a bicycle a sports car just because they both happen to have wheels. But don't worry, we're fixing that confusion right here, right now. Here is our roadmap for today's explainer. We're kicking off with the jargon mix-up, then we'll define AI agents to set a baseline, explore the Agentic AI upgrade, put them head-to-head in an intern versus project manager showdown, and wrap up with why this distinction actually matters in the real world.
Section 1. The jargon mix-up, and where this whole vocabulary collision actually began.
Think back to about 3 years ago. Marketing departments got a hold of the word agent, and they applied it so loosely to basically any large language model that had even a single tool attached to it. It was the absolute peak of the hype cycle. If a chatbot could search the web exactly one time, boom, it was suddenly rebranded as an agent just to sound cutting edge. But then, around a year ago, true multi-step autonomous loop systems actually started appearing. And because the word agent was already heavily watered down by all that marketing, the industry needed a totally new term for this genuine leap in capability. So today, that term is Agentic AI. The terms got completely tangled up in the public consciousness, but they describe very, very different levels of technical sophistication.
Section 2. What is an AI agent? Let's establish our foundational baseline.
If you strip away all the marketing hype, an AI agent is fundamentally a single-purpose system. It's built around an LLM. It perceives your input, decides on an action, and uses a tool to complete one specific task. It's just sitting there, essentially dormant, waiting for your instruction to perform one well-defined job. Think about what fetching a file or checking your calendar actually looks like to a machine. You ask a question, the model converts that into an API request, hits your Google Calendar, grabs the data payload, and formats a response right back to you. One input, one tool, one output.
Picture a basic customer support AI. Step 1, it reads the user query, something like, "Where is my order?" Step 2, it decides to call a specific tool, which in this case is a company's order tracking API. And Step 3, it returns the status response to the user. That's it. It's a single request and response cycle. One decision, one tool call, and the loop is closed. We've all interacted with these bots, right? And we all know exactly how frustrating they can be the very second your problem steps even slightly outside their predefined boundaries. They can't adapt, they just execute the single path they were given.
Now, I want to be super clear here. This is not a lesser technology. Single-purpose agents are incredibly useful, and they power the vast majority of AI features we all use today, from email drafters to basic coding assistants. But they hit a hard ceiling. Why? Because they don't plan multiple steps ahead, and they absolutely do not proactively correct their own mistakes if something goes wrong. If that order tracking API we just talked about goes down, the agent just throws an error, says it can't help you, and stops cold. It doesn't try to find another way around the problem.
Section 3. The Agentic AI upgrade. This is where we shatter that single loop ceiling.
So an agentic AI isn't just a single bot waiting for a prompt. It's an entire system of components. It autonomously plans, executes multi-step tasks, evaluates its own progress, and crucially, adjusts its approach with minimal human intervention. And minimal human intervention in a business context means you can literally walk away from your keyboard. You can give the system a complex goal on a Friday afternoon, and it works continuously. It's making hundreds of micro-decisions, trying completely different paths when it hits roadblocks, and then having the finished deliverable sitting there ready for you on Monday morning. To truly be considered agentic, a system generally relies on 5 core characteristics. First up, autonomous planning. It takes a big goal and actually breaks it down into subtasks itself. Second, tool orchestration. It strings together multiple tools dynamically based on what it learns at every single step. Third, and honestly this might be the most important, self-reflection and correction. It evaluates its own work, spots its own errors, and revises its plan on the fly. Add in persistent memory and multi-agent collaboration, where specialized bots hand off work to each other, and you have a truly agentic architecture. Just think about a 10-second hypothetical here. You ask an agentic system to research a competitor. It plans the search, orchestrates web scraping tools, reflects on whether that data is actually accurate or just marketing fluff, uses memory to recall what competitors you asked about last week, and then collaborates with a specialized formatting agent to write the final polished report. It is a whole ecosystem working together.
Section 4. Intern versus Project Manager. The ultimate side-by-side showdown.
When we put these two head-to-head, the differences are night and day. Notice the difference in scope. An agent handles one well-defined task, while an agentic AI takes an open-ended goal and actively breaks it down. For decision-making, the agent makes a single choice. The agentic system makes an ongoing sequence of adaptable decisions. In error handling, this is massive. An AI agent usually just fails or gives you a broken answer if an API is down. An agentic AI evaluates that failure and attempts a self-correction. Then there's the structure. An agent is usually just one model and a small toolset, whereas agentic AI relies on an orchestrated multi-agent workflow engine. Multi-agent workflows are one of the hottest topics in software engineering right now, precisely because they allow incredibly complex, layered processing that mimics how an entire human department actually operates.
Listen, if you take away just one single thing from this explainer today, let it be this anchor analogy. An AI agent is your capable intern. You give them one specific task, they go do it, and they come back with the result. If they hit a snag, they freeze and wait for you to tell them what to do next. Agentic AI, on the other hand, is the project manager. You give them a broad goal, they break it down, assign the subtasks, check the work, fix the inevitable issues along the way, and deliver the finished project entirely autonomously. A project manager doesn't let an intern accidentally deleting a row in a spreadsheet derail the entire launch, right? They restore the backup, fix the process, and just keep moving forward.
Section 5. Why this distinction actually matters. The real-world impact on your careers and your products.
Using the right vocabulary is really just the tip of the iceberg here. For developers, if you walk into an interview and claim you built an agentic system when you really just wrote a Python script that calls an OpenAI API once, you are going to fail the technical round. Hiring managers want to hear about planner-executor patterns, state management, and multi-agent workflows. For founders, knowing this difference prevents extremely expensive over-engineering. Remember, compute tokens equal real money. Every time an LLM thinks, it costs you. An agentic system burns through compute tokens and requires complex, expensive infrastructure to maintain. If your product only needs a capable intern to fetch a file, please do not pay the ongoing salary of a project manager. Over-engineering burns startup capital faster than almost anything else. And finally, this is the prevailing industry trend. Every major AI lab is racing toward true autonomy, moving far, far beyond basic conversational chatbots.
So how do you actually get hands-on with all this? Well, here is the perfect learning path. Start small. Step 1. Build a single-purpose agent that makes one API call using basic function calling. Once you have that down, Step 2. Graduate to orchestration frameworks like LangGraph or CrewAI to learn how stateful workflows operate. Step 3. Study emerging protocols like MCP, that's the Model Context Protocol, to understand how agents seamlessly connect to live data sources. And finally, Step 4. Build a final project. Create an end-to-end research assistant that actually self-corrects its own draft before it ever shows it to you. That is going to teach you more than 100 passive tutorials ever could. You have the tools to build incredible things right now.
I want to leave you with this final provocative thought to summarize everything we've covered today. An AI agent does a task. Agentic AI runs a mission. One is a brilliant reactive tool, the other is a proactive, self-correcting system. The leap from task to mission is exactly where the future of software is being written right now. So, looking at your own projects and your own goals, which one will you build next?